I am Antón Álvarez from WWF Spain, and my project is to make the idea of the Iberian lynx. Okay, the Iberian lynx is one of the unique. There are not a lot of species that we have been in endangered, then in critical endangered, and now is it just endangered? And in the next year, more or less, is going to be vulnerable. So this is a really good history, but for me, is more work because because like there are 3 years in a row that we have a growth of more than 30% of the population, but we are the same team monitoring. So we really need to speed up the AD process with computer vision. We have like more of 20 years counting the total population. We are not doing estimates. We are still like counting, trying to count it. I don't trust this number. For now, it's really impossible to count all the IDs, but we try to do. And the way is like that. It's a PDF, and in the past was I don't know how to say
a binder.
A binder. And this is a really old picture to show the people 20 years ago how to do that. I mean, this is like the Iberian lynx have a code pattern that is possible to identify each individual. So go to try to do with computer vision. The first thing that I think here was my data set. My data set was a lot of links of ID, and I tried to don't use camera trap and Melanie. I tried to bring here a really different data set with a totally different images, like images with color, without color, with color, without color, cap, adult, camera trap, handheld data, also sanitary checkup. So it's a really heterogeneous data set. But just coming here, in the first week was, okay, we're going to do the split of the data. And what suddenly say, okay, for me, this is a really easy task to make the ID. But I think that all this picture are the same ID. This is Alfonso. Is my field technician is Caleta Alfonso, and it is the same name. And for example, here is the same pattern, but it's difficult. Sometimes it's difficult to look that is the same animal, because the Iberian lynx is really small and also is like really maneuverable, and they change a lot of codes. So I just deleted all this case from my data set and just try to make the ID with the easy case, just with the easy case. What I want to say, yes, and also it's like this data set, I have had a lot of annotation, so for me it was easy to subset this data set because I was like, this was no canonical post, no canonical post, canonical post. So I just would go to the data set, filter, and I did a lot during these 3 days. I have been iterating a lot and changing my data set, going again, modeling. So it was a little bit frustrating, but so also only good quality, because there are a lot of that data is coming out. So there are a lot of images with medium blur that I throw out, and also canonical posts. And this is the problem. Here is really easy to see in this, that here is more difficult because the malleable of the body. So as Melanie explained, that there are like 2 big sub-tasks inside the ID, and it's the closed set and the open set. For me, I was really interested in the open set because I want to apply this at the real world. And for me, it's really necessary to be open set.
With 30% growth in your species population every year, yeah, the open set problem is a big one.
Yeah, it's like I need that. So I create that in one of the iteration. I create that, but in the first week I only create that, and it's like the first thing that I did is I take one ID and throw to the text, and the other ID, the other was known by the algorithms, and one picture to the training, one picture to the debug, and the other picture to the test. So I keep several ideas just in the test. And also for the closed set, that is the easy task, I split all the images between train, val, and test. I don't know what is that. Okay, this is my real meat that's growing 3D. And the computer vision approach at Melanie was Pi. That's Pi come from FaceNet, and I think that I need to understand better FaceNet because for me it will be really helpful. And I have deep a lot in this paper, but not in the one. And maybe this is really necessary to not have more knowledge in the Pi. More or less, this is the same. I don't know how to say schema, but okay. The same picture that Melanie saw, and I am not going to say a lot. And also, I think in the first presentation, I say that I'm going to use ResNet, but I have used several backbones. But the things that is more important here, and that I am using the triple loss to try to create an embedded space, and with a key neighborhood classification, try to know which ID is. Okay, and also, this is not new. Okay, it's new because this paper is from this year, I think. It's not, but it's like, I am not the first boy in the world that I try to do. So, I suppose that is possible. Like, and also it's like, there are like two big algorithms to do the ID with cats, with spelling. That's one thing that is so important. I think that things are totally different than the zebras. That the zebras are really easy compared with the lynx. When I see several pictures of zebras, they like always saying the same, more or less, and the cats are cats, like all the time. Come on. And the thing is like, so they want a paper of this year making the comparison of the two individual identification. Tanya just told us about the hotspotter and with the Pi. And also this is a comparison with the snow leopard between the hotspotter and with the Pi, and combining the two algorithms was better rank 1, better rank 5, that the two algorithms are. And one thing that for me is very important to translate is like, I am not interested in rank 1. For me, it's really good. A really good rank 10 is enough for me. It's like, okay, come on. It's like, we have several individuals now, and we have to check a lot. So only to filter a lot, for me, it's like, I have gained a lot of time in my life. Okay. So the code base that I have used was Pi, that was the Weaver, I don't know how to say that, but Weaver Pi version 2, and also for hotspotter, I use the hotspotter in the Weaver in a container, in a Docker container. So one of the first difficulties that I have found is the overfitting. This is not new, and also the Pi overfitting a lot. So this is my training. I have tried several. So I think that more than models. Yeah, this is more than 50 experiments that I have tried, but never work. Not generalize a lot in validation. So I do my best, but the thing that I have trained, I have trained different backbones, efficient net, ResNet, also ResNet with different weights. I have tried to weight with the snow leopard, with the ImageNet. Nothing. Also, I think the foul is Adam. Come on, maybe I don't understand a lot what is happening. So I think to Italian descent. Also, nothing. It's like, oh, maybe if we change the margin of the triple loss, maybe we're closing, making all the IDs closing. Nothing. It's like I have tried a lot of things. And also, it's like we have overfitting. So I applied tons of documentation. No work. So I have changed the learning rate, change the input type. I have changed all, and also like I changed from open set that I was really interested to closed set because it's like, okay, are the same ideas, so maybe are doing better with a closed. Nothing. For me, it was really funny because when someone come to my computer and said, "This is my task," and I was say, "Come on, this is a really difficult task," and it's the truth, but I need to solve that. So more or less, this is my preliminary result. But this is really important. This is a not fair comparison because I was in a hurry and yesterday night I don't want to work a lot. So this is like the pie with the efficient net, with the snow leopard without chain, and the rest next with the snow leopard chain in my data set. And the hot spotter always perform better than the rest net.
Is this on your validation set?
Yeah, but it's not the same validation set. This is why there is no fair comparison.
Yeah, sure. But also, I guess your rank 10 is like 70%. It's not so bad.
Yeah, it's not so bad.
Okay.
No, and also it's like
It's so bad.
no, but it's like I was like, I will hope I come here thinking like, I'm going to save my life, and it's like maybe it's helpful. It's helpful because in the I don't know why. Okay, I'm going to go there, but I think that it's possible to make a fierce score of that, and maybe it's a little bit bigger.
A question. In a given location where the photograph comes from, so you have the location, how many animals do you expect to be visible, to be there?
Not a lot, but we try to figure out that in the processing, like, because this algorithm then I want to be that is implemented in Wildbook, and in Wildbook you can generate a small project and only do the query so a small, like in this happy state I know that there are these individuals, so I can configure a query inside Wildbook to only do the query for that IDs. So this is really helpful.
So when
maybe you could, maybe you could try to incorporate that type of metric here. So like split this up based on the regions and see what your performance is there.
But I don't want to do that because my bigger problem is if there are links that is from my area, every people know what I really well. That I wanted to be that this computer vision approach could be really helpful is when links from 300 kilometers suddenly appear here. And I am not to do the query with the closer one. I want to do the query one versus all population, because I want to know that there was a link 300 kilometers far that come here. Yeah.
You also want to use this algorithm to look for errors in your database.
Yeah.
By looking at all the individuals to see if there are pairs you didn't make over time. And if you're always doing that subsetting and limiting the algorithm, you're not building for that case about the global query.
Yeah, this is true.
So when we see the rank in the set, how many are there in the set you tested here? Are there 1,000 or are there a subset? Like
Fuck. There's one there, but it's not there. No, it's not there. I think that here is 50, something like that.
50.
Yeah, I think that it's 50, 54. But
So if we think of your 1,000 animal data set, which is 20 times bigger, we should multiply the numbers at the bottom by 20 in some sense. 20, that's good.
Okay, next step. Like in the first week, we have this amazing talk, so maybe I can apply that to my ID problem. The post estimation. With the post estimation from arithmetic, we can maybe it's possible to apply deep black cap for pre-processing. Know if this is the first forearm is visible and select that and create only do the right deal with this part, also with the face, because with faces, time maybe work really well, and also with the flank. And also one thing that could be really helpful is like, here we have like shoulder and the hip, and if these points are really, really close, maybe it's because the animal is in that way. So we can weight, this is like, is really small, so this weight will be really, really low. So we can do this kind of stuff that could be, oh, this is amazing. And also from silver Susie, we can create the texture station, because sometimes the animal, when the animal is bathed, then you have the animal, maybe some videos, long videos, doing like around the camera, and you know that at the same ID, so you can do the texture structure and do the pie of the hot spot. But the other lecture, that keep it simple, stupid. And I think that we need to apply that. Okay, the first thing is to try to improve the hot spotter. I know that the hot spotter OOD in the camera track, they really focus in the background. So maybe preprocessed with instant segmentation before the hot spotter is the first short time solution that we are going to take this course a little bit here. And also it's nice. Like, I don't have talk about that, but this is, I think that this is spatial verification in the hot spotter.
Yep.
This is really good, not good, but a lot of sense that with the spatial verification of in the links will be a really small. And I'm going to try it. So that's example, because for me it's like this is really difficult to make the ID. If, for example, it's possible to do the match with really low images here. If you had a really local area that look really similar, it's possible to match, and this is good. The spatial verification is like, for example, there's here some information, here some information that maybe match, but not in this, not just together. This is that the links are this make a lot of sense. And the other thing that was okay. So the instant segmentation could be really helpful to improve the hot spotter and how to improve the pie with area of interest. Just I have manually annotated all my data set, but yesterday night I was really tired and I don't run that model, but I think that this could be really helpful, and also it's like a simple solution before to try that. This is really difficult, that maybe I could pass a lot of time trying to do that, oh, this will be amazing, but come on, first try that. I am working in that, but, and also the other thing was that incorporate pie and hot spotter with a score fusion, but for me it's really important to think of in this way. I think that only one algorithms are not going to solve my problem. But there are two algorithms that I can apply to the links, and they are different. Like hot spotter are really sensitive to deformation. If the pattern is like change a bit, they don't look at that. But it's really good to small local similarities. They are really good to share in that. And the pie is the other. It's like it's insensitive more or less to deformation. So in this part and this part, maybe pie are going to do a good work. And in this part, maybe hot spotter are going to do a good work. So maybe are going to be a good partner to use the fusion of that algorithm. And I think that this is my responsibility because I have the knowledge of my domain. I need to create a really good data set to test all this experiment. And also it's like my goal is to apply that, and my wish is to serve that algorithms in the platform, the Wildbook for Iberian lynx, that is to study, identify, and protect the Iberian lynx, because my goal is the protection of the Iberian lynx. And also, it's really good to remember that always, unless until you do magic, a human expert in the loop need be in the loop. It has always needed a human verification. And thank you so much. Thank you so much for the TAs, for me, and the team of TAs and ITs, especially for you, sir. And thank you so much.
Questions? Yeah, Mel.
Thanks, Anton. Just thinking like going forward and these 3 different types of images that you have, are you planning to still collect all 3 different types, or would you prefer to concentrate on like 1 or 2 of those kind of images? Like, is there one of the 3 that you think may be causing some problems, or?
I don't know what to do because for pi, I know that this one, and this one are really good. For pi, no, for hotspot.
Yeah.
So, and we have already this image. So, if I want to apply that in a real problem, I know that we are going to have this image from some IDs. Maybe I can split in only camera trap and other IDs with the 3 type. But for example, for me in my work, I usually do a re-ID with these images. So for me, it don't make sense to throw these images away because in the real, we are going to have it. But also, I think that it's difficult to focus only in camera trap in my task because for a segment of picture of camera trap, sometimes I only use one. The other are not good enough to do the ID. So it's not just, oh, I have tons of images of lynx. It's like, okay, but for ID, you only have one of a really big sequence of pictures. And I don't know. And also, they make a lot of different, if you bait the lynx, they have a different behavior in front of the camera, and they are different. So I think that step by step, but the first thing is like iterate in the easy tasks, and then they are going to doing more complex things.
Other questions? Yeah.
So there is an old technique from 20 years ago called SIF.
That's what
Yes,
hotspotter
this
is.
is hotspot.
Okay, hotspot.
Yeah.
And so that seems to work.
Pietro's like, back in my day.
That's back in younger people's day, and twice as old as that.
Twice as old as Sid. Yeah, Abby.
Do you see like sort of qualitatively a difference in matching quality for like daytime images versus nighttime images? No, so you're able to match equally well daytime and nighttime.
Me? Like person?
Oh no,
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 like
sorry, with
algorithms.
hotspotter.
The hotspotter, I don't have. No, I don't. For me, there. I don't know. I have a lot of pictures here. For example, this is a bed, and it's always. Sometimes it's more important the quality of the images, not important if it's day or night. And for me, it's like in my experience using hotspotter, I don't have, but I only answer the question as a user. I don't have to do any metric with that. But also, it's like this example, this is done that.
Yeah, wow. That's impressive match.
Yeah, but there are a lot of that with hotspotter. You know?
So we've been working on the ranking and recall problem for the past 3 weeks. We could consider looking at your problem as a verification problem as well, where you're given 2 images and then the algorithm just tasks with saying yes or no. And you could build a case where if your ranker is a weak classifier, you could then just look at more results over time and then feed them through a separate network that just does yes, no, yes, no, yes, no on the pairs that are found. So other than trying the areas of interest, trying various different algorithms, we could try making a pipeline, and that might help boost performance overall. So many different things to try.
And the segmentation, there's this DeepMap model that works really well for animals, where if you give it a box, it gives you
Yeah.
segmentation.
I try because it's like, have a competition this year.
Yeah,
You
yeah, yeah.
pre-process the images with that.
Yeah,
And I
they
say,
look really cool, right?
yeah, and I was, oh, this is amazing. I'm going to try to do that. And suddenly it's like, okay, I don't have time to. But,
No, but maybe going forward.
yeah, but I have think about that.
Cool. Well,
Thank you.
awesome. Thanks, Anton.